This is a truck. There is a box on this truck. This is motion of truck. This is a truck. This truck is in motion in this direction. Rear side of truck is open. ये जो पिछला हिस्सा है ये ओपन है. A box of mass 40 kg is placed at a distance 5 meter. At 5 meter here there is mass 40 kg is placed. As shown, coefficient of friction between box and truck is 5. The truck accelerate at this from rest. Initial velocity of truck is 0. Truck start from rest and accelerate at this. At what distance from start of truck the box will fall? This is the question. Again, truck moving in this direction, rear side is open. At 5 meter there is a box, mass 40 kg. It is placed. The truck start from rest and accelerate at this. At what distance from start of truck? Truck कितना distance travel करेगा when box will fall? Here is action. So there will be what? Reaction. Action. Is equal to reaction is equal to force. MA. M is 40, A is 2, 80 Newton. This is reaction. Action, MA. The reaction is same. Now then, here is force of friction. This is mg. This is normal reaction. And F. Mu R. Mu mg. Mu 0.15 m40 g 10. It is what? 16 Newton. Truck is moving in this direction, there is action. Now there are two forces on box. Reaction backward, force of friction, opposite of reaction. So there is net force in this direction. Net force on box on rear side, that is F dash. It is 80 minus 60, it is 20 Newton. S dash 5 meter distance, this box, this is force on box 20 Newton. How much distance is had to travel this one? तो टाइम निकाल लो वो. How A dash F dash by M, F dash 20 by M, 0.5 meter per second square. So S dash ut plus half at square. What is this A? It is A dash. S dash is 5. Box was at rest. Half A dash 0.5. What is this T square? It is 10. 0.5 T square, or T square is what? 20, or T is what? 20 root second. In this time box will fall. Then what is distance traveled by truck? Now S. We have to calculate this distance. Ut plus half at square. Start from rest. Half A. Acceleration of truck is 2. T square is 20. This is 0 plus 20, or S is 20 meter. Two masses, 5 kg and 10 kg, rests on a table against a wall as shown. A force of 200 Newton is applied as shown. Coefficient of friction between masses and table is 0.15. Calculate reaction of wall. Second, force of A on B and B on A. What happens if wall is removed and this is that figure? This is wall, this is mass M2, B object, B mass, this is mass M1, say it is a force 200 Newton. This is the question. Two masses, M1 5 kg, M2 10 kg, rest on a table. This mass, they rest on this table. This is table. Against a wall, a force 200 Newton applied as shown. Coefficient of friction is this between masses and table. Calculate reaction of wall. This will be force of friction. When this force is applied, there is the force of friction is in opposite direction. To find the total force of friction, subtract it from this. This will be action, the same will be reaction. First, force of friction, that is F1 plus F2, that is mu M1G plus mu M2G. G10 take G this mu common, G common, M1 plus M2, mu 0.15, G is 10, M1 plus M2, 5 plus 10, 15, it is what? 0.5 Newton. This will be the applied force. This is force of friction. Action on wall. (200 minus 5, this is what, 5, 7, it is what, 7 and 1 Newton. Reaction of wall, same. One answer is there. Second, force of A on B. This is applied force. This force is in reverse direction. Force of friction on mass M1. Case second, force of friction on mass M1, that is F1, that is mu M1G. This is mu M1. M1 was 5, G was 10. It is 7.5 Newton. Therefore, force of A on B. This is the applied force. This is force in opposite direction. So this is 200 minus 7.5. And it comes out to be 5 to 9 1 Newton. Hence, force of B on A this is force of B on A. Action, reaction, equal and opposite. Third, wall removed. Masses will move. With acceleration. A is net force, total mass. MA, net force on wall was this one. Total mass, it is 15. So acceleration is what? मीटर पर सेकंड स्क्वायर. चेक करना इसको एक बार. A cylindrical drum of radius 3 meter. This is that cylindrical drum. This is a cylindrical drum. radius. This is radius. This is axis of rotation. Axis of rotation of drum. A cylindrical drum of radius 3 meter is rotated about its axis with RPM 240 RPM means 240 by 60 RPS means 6 hertz. This is what? Frequency. This is a drum, cylindrical drum. This is axis of rotation. The radius is 3 meter. It is revolving with this frequency. Mass of man is 70 kg. A 70 kg man on floor of drum is in contact with wall. Yeah, this is a man. This man is on floor. This is what? Man. It is on floor of this drum. This is floor. And it is in contact with wall. Coefficient of friction between wall and his clothing. Mu 0.1. At what speed, angular speed, the drum is rotated so that the man remains in contact. किस angular speed से rotate करें कि the man remains in contact if this floor is removed. ये floor निकाल दिया नीचे से, the man remains stuck to the walls, he not fall down. This is the question. Take G this. Now forces, weight will act perpendicular to ground and downward. Force of friction will act. Normal reaction always perpendicular to surfaces in contact. F, force of friction. R, normal reaction. Weight downward, force of friction in opposite direction. He will not fall from figure. F should be equal to mg, and this normal reaction, it is towards center, so it will provide the centripetal force. V r omega. V r omega, or R is mr omega square. This is centripetal force. Dividing first by second, F by R is what? mg mr omega square. M goes with M. F by R is mu g r omega square. Mu F by R, or omega square g mu r, or omega G mu r root G is 10 mu 0.1 r is 3 under the root. It is 100 by 3 under the root, or omega is 10 root 3. 10 multiplied by root 3 divided by root 3. 10 into 1.732 by 3. It is 1732 by 3. Watt radian per second. If this speed, this drum is rotated, he will not fall down, remain stuck to the walls. Now next, if mass of man is half, what will be angular speed? This is angular speed. This is angular speed. It is independent on mass. As angular speed independent on mass, so remains what? Same. Acceleration of clock Rowley system is as shown in figure. Coefficient of friction between trolley and floor is 0.04. Find tension of string. Take G. This is floor. This is trolley. String. There is pulley. This is a block. Here F20A, here F3A, so this will be what? Weight. This will be what? Tension. Balance it. This will be tension. And as trolley moves, this will be force of friction. So this mass is M1, this mass is M2. This is as shown. This force is, downward force is 3A. This force in forward direction is 20A. What it shows? M1 is 3 kg. Ma, this is mass, this is acceleration. So M1 is 3 kg, M2, it is 20 kg. Mu 0.04. Now here the force will be what? Mg. It weight is your what? 30 Newton. Why? It is M1G. M1 is 3, G 10, so it is 30 Newton. Find tension, first find acceleration. Downward motion of M1. F3A. From figure 30 minus T, number 1. Forward motion of trolley. F20A is T minus F. Figure says This is D. What figure says? In forward direction net force is T minus F. Or T is T minus F mu R. T is D, mu is 0.4, M is M2. M2 is what? A, MA 20. G is 10. It is D minus what? 80. Third. Find first acceleration, then we find tension. Adding first and third. First is 3A, third is 20A, T goes with T. T goes with this T. This is minus, this is plus. So it is 30. It was 0.04. So it is 8. Minus 8. 23A is 22. A is 22 by 23 meter per second square. Putting this in first 3A 30 minus T, or T comes out to be, take T to this side, 30 plus, take this to this side, take T this side, take this minus it is 30, solve it, say it will be 2.8 to 727 what? Newton. So this is all about force and friction, this unit.